voltage regulator. Here's a block diagram for a DC power supply. We've got an AC input, presumably from mains, so it's going to be a high voltage AC. Transformer is going to step this down to be a low voltage AC. Rectifier and smoother is going to provide a smoothed DC, although it will still have some ripple. The voltage regulator here is to maintain a very steady DC output. It's going to be very steady. It doesn't matter about minor fluctuations we might get from here or from here. And here's a sample circuit that we could use as a voltage regulator. We've got an op-amp, we've got a MOSFET, and we've got a Zener diode and a resistor. So a very simple circuit. The Zener is going to be providing a reference voltage, and if we have a look here, we've got Vout is connected to the inverting inputs here, providing some negative feedback. And as usual with op-amp circuits, if you've got negative feedback, then the op-amp's input is going to be kept the same, which means that Vout is going to be equal to Vref. So Vout, which is going to the inverting input, equals Vref, which goes to the non-inverting input. In this particular case, we've got the op-amp is going to be controlling the voltage, but the role of the MOSFET is to source the current. If you remember that op-amps can only source or sink about 10 milliamps. So if you're going to need a larger current than that, you're going to need the MOSFET, and that draws the current directly from the smoother directly to Vout on there. A few practical considerations. The op-amp output to the gate of the MOSFET has got to be at least the threshold above Vout. So in order to get this conducting, we need at least the threshold voltage between the gate and the source. So the output here is going to be the threshold above the reference voltage. Also notice that we're powering the op-amp from the smooth power supply here, and remember that from the output, when it saturates, it's going to saturate around about 2 volts below the supply voltage. So we're going to lose a couple of volts to get to here, and then we're going to lose another couple of volts across here. So in order for Vout to be a steady voltage, we're going to need to make sure that Vin from the smoother is at least a few volts, because we're going to lose voltage here and we're going to lose voltage here. So Vin's got to be at least a few volts above the reference in order for Vout to equal the reference.